In this lesson, we will look at properties of logarithms. Inverse properties. Recall, b raised to the power a equals c if and only if log to the base b of c equals a. It follows that log to the base b of b raised to the power x equals x and b raised to the power log to the base b of x equals x for x greater than 0. Examples. Log to the base 5 of 5 raised to the power 10 equals 10. The natural log of e squared, which is equal to log to the base e of e squared, is equal to 2. And e raised to the natural log of 5, which is equal to e raised to the log to the base e of 5, is equal to 5. Let's next look at algebraic properties. Let g of x equal log to the base b of x be a logarithmic function where b is greater than 0, not equal to 1, and let u greater than 0 and w greater than 0 be real numbers. Then we have the product rule. Log to the base b of u times w equals log to the base b of u plus log to the base b of w. The quotient rule. Log to the base b of u divided by w equals log to the base b of u minus log to the base b of w. And the power rule. Log to the base b of u raised to the power w equals w times log to the base b of u. You can refer to your textbook for proof of these rules. And we will use the rules to expand a logarithm, and we will simplify as well. The logarithm is log to the base 3 of 243 divided by x squared plus 9. Using the quotient rule, I can write this as log to the base 3 of 243 minus log to the base 3 of x squared plus 9. Log to the base 3 of 243 is equal to 5, so I will write my expanded logarithm as 5 minus log to the base 3 of x squared plus 9. Okay, next we have the natural log of square root of y over x squared minus 4. I'll start with the quotient rule. I'll write this as the natural log of square root of y minus the natural log of x squared minus 4. The square root of y is equal to y raised to the 1/2 power. And I can factor x squared minus 4 into x minus 2 times x plus 2. We can then use the power rule to rewrite the natural log of y raised to the 1/2 power as 1/2 natural log of y, and use the power or the product rule to write the natural log of x minus 2 times x plus 2 as the natural log of x minus 2 plus the natural log of x plus 2. And we'll finish off with 1/2 natural log of y minus natural log of x minus 2 minus natural log of x plus 2. Next, we'll write an expression as a single logarithm. The expression is log x plus 3 log y minus 1/2 log z. Okay, so I'll start by using the power rule to write 3 log y as log of y raised to the 3rd power and 1/2 log z as log of z raised to the 1/2 power. Log x plus log of y cubed is equal to the log of x times y cubed and I'll finish off with a quotient rule. I will write this as log of xy cubed over z to the 1/2, which I will actually write as a square root of z. Okay. Next, let's write another expression as a single logarithm. This time we have log to the base 3 of x minus 4. So I want to write 4 as log to the base 3 of something. So I have log to the base 3 of x minus log to the base 3 of whatever we get from 4. So what do we get? Well, we want 4 to equal log to the base 3 of something, I'll call it a question mark. And this is the same as saying 3 raised to the power 4 equals this question mark. Well, 3 raised to the power 4 is equal to 81. So I know that I'm taking log to the base 3 of 81 to get 4. And so I'll simplify. I have log to the base 3 of x minus log to the base 3 of 81. I can write this using the quotient rule as log to the base 3 of x over 81. Try on your own. Write the expression log to the base 2 of y plus 3 as a single logarithm.